Hello, welcome to yet another video on learning Power BI. In this video, we will talk about model the data. In the previous two parts, we discussed around 25 to 30% of the topics for PL 300 examination. And in this video, we are talking about model the data that covers another 25 to 30% of learning path. There are 9 modules under this topic. And in this video, we will cover the first 3 modules. If you have just started working with Power BI, this video will help you understand creating and optimizing models using DAX and other related topics. If you plan to appear for Microsoft certification examination, this will introduce the first 3 modules under the topic Model the Data, and these are the 9 modules. We will start talking about the first module called Describe Power BI desktop models, and I would like to jump into an hands-on activity straight away. The sample file that I am using for this activity can be downloaded by you. You can check for the link in the description, and please try to perform all the activities that you see in this demonstration in your system to get a clear idea. I have an Excel sheet showing sales records for all the states in India. For the state column, we do have 2 additional information, namely code and zone. Many number of transactions might have happened in each of the states. Because of this, the name of a state will be appearing in many rows in the state column in this data set. That is a fact, and no one can deny that. For example, if you look at the state column, the name of Andhra Pradesh is appearing in many rows as many number of times as per the sales transactions that has happened in that particular state. Let us now move to another table called states table, which is relatively a small table. In fact, this is another dimension of maintaining the data exclusively for each state, and this table don't have transactional data. The 3 columns called state, code and zone, which were found in the sales table, appear here too. However, the state column looks to be having unique entries. That is, the name of every state appears only once in the state column in this table. Additionally, we have a column called state ID. Assume that we have segments on which sales happened, category of items, subcategory of items, order priority, and so on. If we have all of them in individual tables, and if our sales table speaks only about those relevant IDs, what is the major advantage? The major advantage is we have reduced the number of columns in the sales transaction table. Rather, all of them are kept in different tables, which can be connected together when we want to create a combined report. This is the foundation of data modeling. So I have a fact table in which all my transactional entries are available, and I have many dimension tables which will have supplementary information that should be sought by my fact table. We are now trying to understand the concept of data modeling, and we have discussed about one file called sample 1 in which we have a fact table and a couple of dimension tables. To move ahead in our discussions, I would like to open a Power BI file. Would like to get 2 tables from the Excel file. The states table, which is a dimension table, and the sales table, which is a fact table, I want to load into the model. They are now loaded into my model. I can see that the state ID column from both the tables are connected. The type of connection is called one-to-many, and the technical term for that is called cardinality. If I'm going to click on the properties, then make a small change to keep my dimension states table on the top, then I can see that the cardinality is called one-to-many. The relationship is active, and there is something called a cross filter direction which is currently set to single, and that can be changed to both or bidirection filters if required. I just cancel this dialog box. Now I want you to understand about the one-to-many connection. As we have already discussed, in the states table, the name of one state will be appearing only once, no duplicate entries, whereas it may appear in hundreds and thousands of rows in the fact table depending upon the number of transactions. That is the reason why this is called as a one-to-many relationship. With this understanding, I'm going to pull rest of the dimension tables into the model. The other dimension tables were brought into the model, and you can now see that the fact table is sitting in the center and the rest of the dimension tables are sitting in the corners. This is normally known as a star schema, and you can very well see the flow of direction. The priority table is connected to the sales table through the priority ID column, and the flow of direction happens from the dimension table to the fact table. Similar is the case for states table. State ID column is connecting both the tables. Similar is the case for segment table. Segment ID column is connecting, and the flow of direction is from dimension to fact, subcategory, good to go, category, good to go. So this is called a star schema in which the fact table is connected with all other dimension tables, and the flow of direction starts from the dimension table and goes to the fact table. You have just watched a simple demonstration. Let me quickly touch upon some important points which we have seen so far in the demonstration by going through the slides as quick as possible. We spoke about tables, removing a few columns, keeping them in a separate table, and then connecting them together using a common column. And in that process, we identified something called a fact table and a dimension table. Dimension tables describe your business entities such as people, places, products, or concepts. Each dimension table must have a unique column, which is referred to as its key column. A unique column doesn't contain duplicate values, and it should never have missing values. In this sample, the unique column is state ID. All other columns can be used to filter or group the data. The table that accumulates rows related to a specific business activity is known as a fact table. Often, the values in a fact table are summarized. The difference between a fact table and dimension table, you must be clear by now, and you will be able to quickly find out what kind of a table these two tables are. We have also identified the one-to-many connection, and the most important thing about the relationship is it allows filters and groups that are applied to dimension table columns to propagate to the fact table. We had a good discussion about star schema. Star schema is a mature modeling approach widely adopted by relational data warehouses. It requires modelers to classify their model tables as either dimension or fact. Star schema supports high performance analytic queries. You may now ask me a question. Hey Raja, wait. What is an analytic query? We have not seen anything about that. Correct. We are now moving to the demonstration mode again to discuss about analytic queries and a few more points. We are back to Power BI. Assume that somebody is asking me a question. Raja, can you create a visual to compare zone with reference to the bill value generated by each zone? I'll be happy to do that. I can quickly create a funnel chart, and my task is to group the data by zone and then summarize the entries in my bill value column. So I am grouping the data with reference to zone values, summarize the data with reference to the entries in bill value column, and I can quickly see a result. But you may now ask me a question. Wait, Mr. Raja, you have not written any formula for that purpose. How do you come to know that the northeastern zone has given you 261 millions of sale, and the least one is the central zone has given you 57 million of sale? How do you know that? That is a good question, and that is where we need to think about analytical queries. Analytical queries are the queries that are sent to Power BI when you try to create a visual, and they gives you the result as per your requirement. But wait, Raja, can you show me where the analytic query is working? Can I see that? I can help you to see how the analytical query is running in the background. Let me remove this visual. Let me click on the View tab to open Performance Analyzer, and then click on Start Recording. Then create the funnel chart once again. Each of the steps that was performed are recorded And the final one, the sum of bill value by zone, when I click on the plus symbol, I'm able to see something called a DAX query. So this is the analytical query that is sent to Power BI, which has returned me some results. If you want to see the query, though we may not be able to understand anything out of that if you are completely new for Power BI, as well as data analysis expressions, we can just have a look into that. If you want to really have a look into that, you can copy the query and then paste it in any text editor to view the query. And this is what it is. We are not going to dive deep into this query since we are not going to write this query at all. That is being taken care by Power BI. To give a quick summary on analytic queries, an analytic query is a query that produces a result from a data model. When you try to create any visual in the background, the visual will send an analytic query to Power BI to query the model. In general, there are 3 steps involved in an analytic query. Filter, that is slicing activity to target relevant data only. Group, that is dicing activity to divide query results into groups. Summarize, to produce a single value result such as sum, count, and so on. Not all analytic queries need to perform all these 3 actions. In the demonstration, you saw the creation of a funnel chart in which grouping has happened, summarization has happened, but filtering activity was not done by me. And it is high time for us to understand how filters can be effectively used in Power BI. We are back to Power BI. We have configured this report visual a few minutes ago, and let us see how we can apply a filter for this. When I look at the filters pan, I'm able to see 3 different options. Filters on these visuals, or filters on this page, or filters on all the pages. Let us start with applying a filter on an individual visual. I click on the visual, and this visual is currently making use of 2 columns from my model. Column number 1 is the zone column that is coming from a dimension table to group the data. Column number 2 is the bill value column that comes from the fact table to summarize the data. Now I want to filter the data. Let us say, for example, to find out the category of items. So I bring the category column to the specific location called add data fields here, and then I would like to see the data, this funnel chart, only for technology items, and that has been done. A filter is now applied on a specific visual. Let us now look at a different scenario. I have created 2 visuals in another report page. One of them is a column chart, one of them is a donut chart. And then I will be able to see a place called filters on this page. I can pull again the category value to filters on this page location, then choose technology again. Now you can see both the visuals are obeying to this filter. Similarly, I can apply a filter on all the pages in the report by pulling any column of my choice to this well called filters on all pages. Let me now speak about one of the model resources that you need to know, that is called an hierarchy. When I look at the dimension states table, I can see the zone values, and when I hover my cursor to the 3 dots, which is nothing but more options menu, I'll be able to see an option called create hierarchy. Now you can see that a zone hierarchy has been created. I'm now going to the state column and then click on the same 3 dots menu. I can create a hierarchy based upon states. Also, I can add it to an existing hierarchy in the same table. So I'm going to add it to zone hierarchy. Now you can see that the zone hierarchy is consisting of 2 of my columns, zone column and the state column. You may ask me a question, Raja, what is the use of this? In the previous example, you spoke about a funnel chart visual in which you just made use of 3 different columns for grouping, for filtering, for summarizing. Now we are talking about creating an hierarchy, and what is the purpose? The purpose of having hierarchy is simple. If you can create an hierarchy in the model and use it for visuals, then you will be able to drill down to the lowest level in the hierarchy. For example, let me create a matrix visual for grouping the data. I am going to call my zone hierarchy. Then you will be able to see the zone values are visible in the screen, as well as you will be able to see a plus symbol. By clicking that, you will be able to see each state that belongs to that particular zone. You can also see the states by using this option called go to the next level in the hierarchy or drill up to go back to zone level. If I'm going to add a summarization factor here, let us say our bill value column, then I get a zone-wise bill value reporting, that is the configured visual. More importantly, when I hover my cursor to the icons here, I'm able to see one particular dialog. Click to turn on drill down. When I click that, the dialog box now says drill mode is on. Click data point to drill. What is the purpose of this? If I'm going to click on northeastern zone, then you will be able to see the data points that are related to the northeastern zone. I can go back by clicking the drill up button. Please be aware, clicking this go to the next level will take you to a state level report. You may need this, or you want to see only those states that belong to a specific zone, then you just need to double click on the zone's name. So this is the purpose of using an hierarchy for creating a visual so that you can drill up or drill down to the required level. So when you do the drill down or drill up activity, you can also notice that the zone, which is an hierarchical level information, is used to filter the data. It is already being used to group the data. It is now used to filter the data. However, hierarchies cannot be used to summarize the data. We have almost reached the end of this demonstration for the first module. I would like to make a statement now. The model resources that can be used to configure a report visual are columns, hierarchy levels, and measures. In star schema, the key numerical column in the fact table is known as a measure. These three resources can be used to perform the following actions, which happens via the analytic query: filtering the data, grouping the data, and summarizing the data. However, not all these resources can be used for all these actions. Raja, can you be specific about your statement? If that is your question, let us quickly check about using columns in a visual. So this is the configured report visual in which I have used a column from the dimension table to group the data and another column from another dimension table to filter the data, and the summarization is happening through a column from the fact table. In the next sample, we discussed about hierarchy levels. Hierarchy levels can be used to group the data and filter the data, but they cannot be used for summarizing the data. Let me now speak about using measures, and I repeat the statement. In star schema design, a measure is a fact table column that stores values to be summarized. In a Power BI model, a measure is a formula written in DAX that achieves summarization. That being said, if I look at this visual closely, I have used one column from my dimension table to group the data, one column from the fact table to summarize the data. Now the question is, can I use the same column called bill value to filter the data? Pretty much possible, and there are two ways in which it can be done. Number one, if I want to see any state where the total bill value is above 50 million, then I have to open the sum of bill value column that is already used, which is currently showing all the states, all the sum of bill value items, in which I can apply a filter is greater than, let us say, 50 million, and then apply filter, then I can see only three states: Gujarat with 81 millions, Nagaland with 62 millions, West Bengal with 52 millions. So this is one way I can use a measure or a fact table column to filter a visual. If I'm going to make a small change in this, instead of 50 million, if I'm going to change it to 5 million, apply filter, now you can see huge number of states showing the value. The topmost is Gujarat and the least one is called Haryana. On the other hand, I'm going to apply this filter in a slightly modified method. I'm going to clear this filter. Then I would like to use the bill value column as a data field to filter the visual. Going to apply the same condition is greater than, let us say, 50 million. Apply filter, and I am not able to see any state. Why? Before trying to understand the answer, let me reduce the amount to 5 millions. Click on apply filter. Now I'm able to see a couple of states, but these two results are completely different from each other. When I am filtering the data for amounts greater than 50 million, in the previous case, it was the sum of bill value column and I had three states showing the values. Whereas if I am talking about is there any value in the bill column which is greater than 50 million, there is no state where that criteria is met on any sale order. What do you mean by that, Raja? Can you explain what is this 52 million for Gujarat and what is this 5 million for Sikkim? From the dimension table called states, I'm able to understand the state ID for Gujarat is 7 and that of Sikkim is 22. If I can go to my fact table, filter the state ID for 7, I'll be able to see the data exclusively for the state called Gujarat. And if I'm going to filter the bill value here for more than, there is no entry. Rather, if I'm going to filter the value for greater than 5 million, then I'll be able to see two different values here. And the summation of this is what shown here as 52 millions. Similarly, if I'm going to filter the state ID column to a value called 22, that is for Sikkim, then I can see only one value here. So, the visual is now filtered for the bill value column greater than 5 million. And then only those states are reported in the visual where at least one row item has a bill value that is greater than 5 million. So please be aware of the difference between these two kinds of filters when you are trying to make use of a measure to filter the visual. In the demonstration, you noticed how to configure report visuals and how can we apply filters on visuals either for individual visuals or for all the visuals in a page or for the entire report, some snapshots to recollect the discussion. We also talked about model resources and which model resource can be used for what kind of activity in terms of analytic query, such as filtering the data, grouping the data, or summarizing the data. That is the end of discussions on module 1. We will be moving to module 2 shortly. Okay, let us begin the next topic. The second module in this learning path is about choosing a Power BI model framework. We need to be familiar with a few terms which are known as Power BI model terms. Some of them we have already discussed, but we'll be touching upon them very quickly. To start with, data model. A data resource that can be queried can be called as a data model. The query can happen via two analytic languages. The first one is data analysis expressions, shortly known as DAX, and the second one is multi-dimensional expressions, shortly known as MDX. Power BI uses DAX. Paginated reports which are available in Power BI Report Builder, Power BI Services uses both DAX and MDX. The feature in Power BI Services called Analyze in Excel uses MDX. We are not going to discuss much about MDX, but these are all basic information that you must be aware of. When you create a Power BI model with report pages, with visuals, etc. in the Power BI desktop application, it will be a single file with an extension name .pbix. However, if you publish the Power BI report into Power BI Services, it is split into two parts as a report and a data set. In general, Power BI data set comes from the published report. However, there could be other data sets in your Power BI Services workspace, maybe from external hosted models such as Azure Analysis Services or SQL Server Analysis Services, or push data sets, or streaming data sets, or hybrid data sets. Our discussions are limited to data sets from models developed in Power BI desktop. We had a discussion about analytic query a few minutes ago. We need to know about tabular models. A set of metadata such as tables, relationships, measures, hierarchies, and other such elements can be used to form a semantic data model. Such a model can be called as a tabular model that can provide a navigation system in client tools such as Power BI and Excel reports. A Power BI model is a tabular model. Tabular models are based on in-memory databases using the X velocity compute and storage analytics engine, which was previously known as Vertipack. This engine uses column-based storage and powerful compression algorithms to provide super-fast query time even with large volumes of data. To produce an optimized and easy-to-use tabular model, it is better to produce a star schema design. We just saw that the tabular models are going to be very useful. Even with the large volumes of data, they can give you super-fast query time. So it is better to create a star schema design so that we can use the tabular model easily. Table storage mode is another important point to note. Each table in Power BI except calculated tables will have a storage mode property which can be any one of the following: import, direct query or dual mode. When data is stored or cached inside the model, queries retrieve data from the local copy, and one such mechanism is known as an import mode. When data is stored in the source itself, only the metadata is available in the model. Queries pass through to this data source. Such a mode is called direct query. In dual mode, queries retrieve stored data or pass through to the data source. Power BI determines the most efficient plan, striving to use cache data whenever possible. The next terminology we need to be familiar with is called model framework, which will be decided by the storage mode. If the data storage mode is import, then you have an import model. If the data storage mode is direct query, then you have a direct query model from the same source group. We do have another model framework called composite model. When data is obtained from more than one source, such a model framework is called composite model. Since we are talking about three different models, naturally a question will come. So when do you need an import model? What are its benefits and what are the limitations? When we speak about the benefits, all types of data sources are supported. Both DAX and M are supported. Calculated tables can be created. Delivers the best query performance. However, when you publish a report to Power BI services, there is a size limitation of 1 GB dataset in shared capacity. If you have a dedicated or premium capacity, you can publish datasets beyond 10 GB if large dataset storage formats are enabled. However, you need to buy licenses for that. And is this acceptable to your business? So the first 2 points are about size limitations, either for a Power BI Pro licenses or for premium licenses. And the other points related to refreshing the data periodically to stay in sync with the changes in the source data. The current scheduled refresh limitations are 8 times a day for a shared capacity, Power BI Pro licenses, or 48 times a day for dedicated or premium licenses. Is this acceptable to your business? Let us assume that you plan to go for a direct query model. You must know the benefits and the limitations in that also. In case of large volumes of data, it is better to keep it in the source and use direct query model. You are free of data set size limitations. Since the queries will be sent to the source always, users get the current information even if your data changes frequently in the source. Direct query models don't need refresh, and if RLS is implemented in the source, it can be effectively used with the direct query model. Had it been imported model, you need to replicate the RLS in Power BI. If you have a security policy that data should not leave the organization, then direct query models are a best fit since your data stays in the on-premises servers. Only the metadata is transferred to Power BI. Though these are all the benefits, there are a few limitations. All types of data sources are not supported. All Power Query transformations are not supported. Analytic query performance can be slow. To give a snapshot, direct query is a direct connection to the data source. Data will not be stored in Power BI model. Power BI will be a visualization layer, then query the data from data source every time. Power BI will store only metadata. Power BI file sizes will be much smaller. So can I say yes or no? You may say yes, you may say no, but be aware that there are a couple of more limitations. Using DAX expressions will have limitations. You cannot write all types of expressions. And one of the major disadvantages of this method is the connection is slower than other types of connection. Every visual in your report will send a query to data source and gets back an answer. For billions of rows, this is certainly a problem. Using Power Query will also have limitations. Many Power Query operations expect the data to be imported data. There is a 1 billion rows limitations on direct query for the visuals in your report. though there can be billions of rows in your source data, just be aware of this difference. We will talk about a composite model which has got brilliant design flexibility. You can choose to integrate data using different storage modes, thereby achieving a right balance between imported data and the pass-through data. In composite models, some analytic query may be responded by the imported data, which could improve performance. If you are using a Power BI data set that is from a remote source, then you can create calculated columns and tables. A few limitations are you will be required to refresh the data like you will be doing in an imported data set to keep in sync with the direct query data. When an analytic query must combine imported and direct query data, Power BI must consolidate source group query results, which can impact performance. So there are a couple of benefits while you use a dual storage in which both import mode and direct query modes are set to be used. This helps Power BI to determine at the query time the most efficient mode to use out of the two to which the query should be sent. Dual storage mode tables work well with the import aggregation tables. They allow Power BI to satisfy higher grain queries entirely from cached data. Slicer visuals and filter card lists, which are often based on dimension table columns, render more quickly because they are queried from the cached data. When you set up an import table with incremental refresh, you can enable the get the latest data in real time with the direct query option. By enabling this option, Power BI automatically creates a table partition that uses direct query storage mode. Owing to this, the table becomes a hybrid table with two types of partitions: import partitions to store older data and a single direct query partition for current data. When Power BI queries a hybrid table, the query uses cache for older data and passes through to the data source to retrieve current data. This option is only available with premium license. You can watch a partial demo on this shortly. Aggregation is a process of loading a summarized data into your Power BI model. This may have limited use but will certainly be required for everyone many a time. You can use the group by option to define a column based on which you want to visualize a result. You will shortly watch a demo on this to get a clear idea. Manage aggregation is a feature in Power BI that can boost performance when you need to use a direct query storage mode. This process involves creating an aggregation table which will be hidden by default. Power BI can choose to send queries to this local aggregation table that will considerably reduce refresh time. You will see a demo on creating a manage aggregation in a few minutes in this video. High time for us to move to a demo on whatever we have discussed so far. We will be moving to the demo part now. I am ready to acquire data from a SQL server, and before I do anything, I want you to have a look into the left side pane in which there are three icons. The first one is report view, the second one is table view, and the third one is the model view. Let me hit on import data from SQL server icon, provide my server name and click OK. I will be now connected to different databases that are available in my SQL server. I am going to choose one database called Global Edge and one table called 2M sample that contains 2 million rows of data. The data is being loaded into the model. You can see the number of rows getting loaded. We are almost reaching the end. Yes, 2 million rows are now loaded into your model. You will be able to see the data physically available within Power BI as a local copy. When you open the table view, you will be able to see the data here. So this is the first point of information. Please make a note of that. I would like to go back to my Power Query editor. In the Home tab, I'm going to click on Transform Data icon. That takes me back to my Power Query editor. I have a look at my order date column, which is showing date as well as time. Assume that I need only the date values and not the time values. I can transform this to give me only the date values. Or I can cancel this step, keep the column as it is, and then click on add column to give me an additional column that speaks only about the date values. Now you can see the date has been split and kept as an additional column, while the order date column is still being maintained in the table. I click on the Home tab, close and apply. Now I'm going to create two card visuals. In the first one, I'm going to call for the total profit value. And in the second one, I would like to get a count of records, which I'm going to do very quickly using a text column and then changing the field value to count. So we have 2 million records loaded. I'm going to save the file with a name SQL import. What do you mean by import, Raja? Because the data from SQL Server is imported or the storage mode is import. But how do I know that? It was done while I was loading the data from SQL Server. Or if you want to know, is there any place from where I can understand the storage mode, you can go to model view, click on the table, and then click on the advanced section where you will be able to see the current storage mode is called import. So let us now save the file once again, close the file, and in the desktop, I'm going to show you the size of the file. The size of the file is approximately 45 megabytes. I am going to perform a similar activity of bringing data from a SQL server, but this time I'm going to use a different storage mode. I'm going to use the direct query option and get the data from the very same database and from the very same table. Click on close and apply to load the data to the model. And now I want you to have a look into the left side pane where you are able to see the report view and model view. So where is the table view? The table view is not visible in direct query mode because you have not brought the physical data into your model. Only the schema has been brought here. So this is the first point about direct query mode. We don't have a physical copy of the data. You may now ask me a question, Raja, if that is the case, how do queries are going to be responded? The queries that you are going to create will be sent to the SQL server and the response from SQL server will be obtained and the results will be shown in Power BI. As in the previous case, I am going to create two card visuals, one of them to show the total profit value and another card to get me the count of records loaded into the model. I get same results which were available while I have imported the data. So there is going to be no difference in the end result whether the data is imported into your model or kept in the source itself. I want to go back to my Power Query editor. Would like to check whether all Power Query steps are possible in direct query mode, and I'm going to click on the same order date column once again, which contains date and time values. Would like to add a column only for the date values, and the Power Query editor is good enough to give me the result immediately. At the same time, giving me a hint, this step results in a query that is not supported in direct query mode. Switch all tables to import mode. It is now clear that some of the M transformations are not possible in direct query mode. Instead, I am cancelling the last activity. I click on the Home tab, click on Close and Apply, back to my Power BI screen. Let me click on the model view. You can see a dark blue color solid line on the top of this rectangle box, which indicates that the current storage mode is direct query. That can be seen from the advanced tab also. So we are now using the storage mode called direct query. However, I have the liberty to change it to a dual mode, and there is an warning message. I'm going to accept that simply. Now, please make a note of the line. It is no more a solid line, but it is a broken line, kind of zebra crossing, which indicates that we are in a dual storage mode at this point of time, in which I'll be able to see the physical copy of the data. You may now ask me a question, Raja, I'm not happy about this decision. Can you go back to your direct query mode from a dual mode? Yes, it is possible. I'm going to hit on direct query mode once again. I'm going to click OK. We are back to direct query mode and I don't see the table view here, which means no physical copy is available in the Power BI file. Alright, we will save this file now, close the file and check the size of the file. This is a 3.02 MB, whereas the size of the file when we used the import storage mode was 45 MB. So this should give you a clear idea on the file size limitations. If you are not bothered about the file size, if you are having a premium capacity license, then you can go for import mode, or file size is definitely a matter of concern for your organization. You can think about using a direct query mode. Again, if you want all the transformations to happen in the Power Query, that is the M transformation, then you cannot use a direct query mode. It is not going to be easy to decide which mode you are going to use, and that can change from time to time depending upon the size limitations, depending upon what exactly you want to get from the Power BI file. Let us now move to the third model called the composite model. I have kept open the calendar template in my screen. If you are not aware of the calendar template that I am talking about, you may kindly check the description to see a link for my two videos on creating your own calendar tables or downloading the calendar table that I have already created for you. Time being, permit me to show you a demonstration on using a calendar template into which I'm going to pull data from SQL Server using direct query. I have typed the server name ready to fetch data from a SQL Server. I'm going to use the same database and same table and click on load the data, and I get a very clear information regarding security risk. When you add a second data source, information from one data source might be included in queries that are sent to the other data sources. Do you want to build this model? I'm going to say yes, because I trust my template. And then I'm able to see the table called 2M sample is now loaded here. But Raja, you used direct query mode. We can see the table view here. Yes, table view is available here. However, when I click for that and when I choose the 2M sample file, this table uses direct query and cannot be shown here. Whereas the calendar table I have created is available here as a local copy. So I'm now having two tables from two different sources, and this can be called as a composite model. There are other tables called basic date and FY tables here. Please ignore them for the time being. If you want clarity on them, you can check my videos on calendar tables. For the sake of this demonstration, I'm going to remove them from this model. We now have only two tables in the model. The 2M sample file is in direct query mode, whereas the calendar table called CY is in import mode. We discussed about one-to-many connections in previous part of the video. So I would like to connect my date column from the CY table, which is a date dimension table, to the fact table called 2M sample through the order date column. Trying to connect them, and then I'm getting an issue called circular dependency. I'm going to close this. Then I'm going to click on the 2M sample table, which is currently in direct query mode. Click an option to convert that into a dual mode, accepting the warning message. And now the storage mode of this table is changed to dual. And now I'm trying to connect the date column from CY dimension table to the order date column in the fact table. I'm getting a dialog box which I need to confirm. I click OK for that, and then bingo, I'm able to connect these two tables together across the date column. But you may be worried about the security of the data. Look, Raja, you converted this into a dual mode. So when I click on the table view here, when I click on the 2M sample, I'm able to see the entire data. This is not acceptable for me. I do agree with you. After creating the connection, I go back to my 2M sample table, go to the advanced tab, and then change the storage mode from dual to direct query again, accepting the warning message. You can now see that it has been converted into direct query. You can see the solid blue line, and when you click on the table view, you will be having a confirmation that you are not able to see the physical data here. Everything is fine, but Raja, will I be able to create reports now based upon the date dimensions in your CY table? For example, if you are going to create a slicer for the year values from your calendar table called CY, and if you are going to create a donut chart to show the names of the countries and then the total profit, and then apply a top end filter to show only the top 5 countries in terms of total profit, will this visual respond to the calendar table's slicing activity or filtering activity? Let us check that. I can see that there is a change. 2019, 2020. Yes, it is now working brilliantly because of the fact that I simply switched a direct query mode into a dual mode, established a connection, and then converted back to direct query mode. So this is a very simple trick that can help you even to use time intelligence measures in a direct query mode. I am now going to provide a demo on aggregation, for which I am going to use this same database and same table from my SQL Server. I would like to make use of the direct query option, fetch data from the required table, and click on transform data. Let us now assume that I have a very specific requirement of creating a simple table in which I just want to see the names of the region along with the number of records per region, and then the total profit generated in that region. So my requirement is very simple. Though I have 2 million records in this data set, my requirement is plain and simple. I just need a consolidated report. If you have similar scenario, it will be ideal to convert this query into an aggregated table. To do that, I can click on the transform data option in the ribbon. I have already selected the region column by which I want to create a table. Then I need to make use of an option called group by. And in the dialog box called group by, I need to choose advanced. So region column will be used for grouping the data. And then I'll be getting a new column for which I am providing a new name, which will count the number of rows per region. And then I want to create one more column called profit, which will sum all the values from the total profit column. If I'm going to click OK, then I'll be getting a very simple table in which the region names are appearing, number of transactions per region is appearing, and the total profit is appearing. So this concept is known as aggregation, which can be done using the option called group by. You may now ask me a question, Raja, this is now converted into a simple regional table. I can understand that this cannot be drilled down further for any other analysis. That's fine with me. But I need to have another table similar to this for item types. I can respond to your query. Before that, the name called 2M sample, I'm going to make a change. I'm going to rename that as a region or region report, and then duplicate this query, rename that as item report, and then move on to my applied steps where I can see the gear icon for the last step called grouped rows. I can click this gear icon to see what was the action that was performed. Instead of region column, I can choose item type to be a grouping factor. Click OK. Now you have your item type aggregation table ready as per the requirement. So this is a simple introduction about aggregation, which may be useful for all of us at least once in a while. So please make a note of this. I am now going to provide a demo on another topic, and this topic is called Manage Aggregation. I would like to get data using direct query from the same database and same table. The 2M sample query is now in my Power Query editor waiting for my command. I'm going to duplicate this query and I want to rename this as AGR_region because I want to create an aggregation table based upon the region, but I want that to be a managed aggregation. So I'm duplicating this and then I'm keeping the region column. Then I'm going to use an option called choose columns to retain only selected columns. For example, I want to have the region column and then total profit. None of the other columns are required in the duplicated AGR_region table for me. I'm going to say OK for that. So I may have 2 million records, but only 2 columns in the duplicated table. I'm going to load both of them into my model, and both the tables are now visible in my model. I'm going to model view, click on the AGR region table, choose the advanced tab from the properties, and then change its storage mode from direct query to import, accepting the conditions. So one of the tables is now in import mode while the other is in direct query mode. Let me go to the report view. Both the tables are still visible in my model. I click on the more options menu for AGR_region table. Then identify a place called Manage Aggregations. Click on that. And in the dialog box, I'm going to use an option to group. The region column should be grouped and the detail should come from the 2M sample table. That too from the region column, and the total profit column should be summed upon from the 2M sample table for all the values in the total profit column. Please make a note, this table will be hidden if aggregations are set because aggregation tables must be hidden. I'm going to click on apply all, then I can see one of the tables is gone now. I have created 2 tables and 2 slicers from the 2M sample table whose storage mode is direct query. However, this particular table in which the region names and total profit are provided is an import aggregate table also. So the moment I'm going to click on any particular item type, you can see that this table is slightly faster in refreshing the data. That is because this AGR table will now act as an internal table, and any query that can fetch data will be hitting this table, and other queries will hit your SQL server. Therefore, there may be a minor time difference between them. The minor time difference may become a major time difference depending upon certain other factors. So the concept of manage aggregation will be useful when you want to have a part of your data as a local copy. So that is the information on this subject. We will be moving quickly to the last demo in the second module. We will now have a quick demo on incremental refresh. The 2M sample file is loaded into a Power BI file and the storage mode is set to be import. Incremental refresh needs your source data to be responding to query folding, such as a SQL Server data, and it also requires two parameters on date and time. For the data that is loaded into the model, I have a date column which is called order date, and the earliest order date and latest order date are shown in terms of a card. Before setting up the incremental refresh, I need to go to my Power Query editor and then create two parameters. And the first parameter should be called as range start, which should be a date and a time column. And the current value, I prefer to use the starting date in my database. So I am typing the exact starting date. I need to create yet another parameter, which I am going to call as range end, which should also be date and time type. And the current value for that, I am going to give an imaginary value along with the time component. And the 2M sample table, I am going to the order date column and filter this using an option called after or equal to a parameter called range start and before or equal to another parameter called range end. Then I need to click OK so that this parameter is now applied. I can click on close and apply, and I will be able to change the start date and end date any time of my choice so that I can limit the data as per a specific year or within an year specific month and so on. So this is one aspect of creating a parameter. The other aspect of creating this parameter is that it is a condition for creating incremental refresh. And for the 2M sample table, I reach the more options menu. Could see an option called incremental refresh. And I'm going to now click on set import and refresh ranges. Archive data starting, I'm going to say 3 years. You need to watch the space in the bottom part. I'm going to type 3 and then I'm going to change this to years. And then incrementally refresh data starting, I'm going to type 10 and then using an option called days. Now you'll be able to see some dates here. Data will be incrementally refreshed from 15/9/2023 to 24/9/2023. You may ask me a question, Raja, what is this 24/9/2023? That is the current date on which this recording is happening. Okay. And the data imported from area speaks about 1/1/2020. You may ask me a question, what is this date? Our data starts from 2017. Since I have given a condition of archive data starting for 3 years, the first 3 years of data will be archived. And the most important thing about incremental refresh is you need to check this box called get the latest data in real time with a direct query. However, this needs a premium license. I'm going to click on this box. I'm going to check this box. I can now see 3 years before refresh date, the data will be archived. 10 days before refresh date, I'll be getting incremental refresh. And on the refresh date, I'll be getting real time data. So this is a very simple introduction about incremental refresh. I may not be able to give any further demo on this. Maybe it will be shown in a future video. Our demonstrations on module 2 are over. I have provided a summary of what I have demonstrated so that you can check it later also. We have completed discussions on module 2. If you have not subscribed this channel, please subscribe, like the content if that is okay for you. Please do comment so that we can understand how we can improve our videos, and do share this with your professional contacts. Thank you for that. We will be moving to module 3 shortly. We are ready to move to the next topic. If you have not subscribed this channel yet, please do subscribe. And if the contents are good, please hit the like button. Do let us know what you think about the videos in the comment section. and please share this channel information with your professional connections. We are moving to the third module in Model the Data topic about design a data model in Power BI. Creating a great data model is an important task. A great model should be simple, comprehensive, and accurate. No one would like to see a data model with hundreds of tables. Try your best to have minimum number of tables. Similarly, the greater number of columns in a table, the more complex it will appear for everyone. Try to remove unwanted columns in your tables. Create relationships between tables in a correct way, as otherwise it could affect the end results. As discussed earlier, one of the best ways to create a great data model is to use star schema. When you load your data into Power BI, the auto detect feature will help you establish relationships between columns that are named similarly, and such relationships can be inactive or active. You need to create correct relationship types such as one to many, one to one, many to one, or many to many. You should also know about the filter direction, whether to use a single direction filter or bi-direction or both direction filters. During the demo on this part, you will come across a model that is not as per star schema. You will also learn about filter directions in this sample. You will see an issue while you create visuals and a temporary solution for the same. Check what will be the implications of this temporary solution and what will be the ideal solution. Configuring table and column properties is pretty much simple. When you go to the model view, when you click on a table, you will be able to see the properties of that. As well as when you click on a column name, you will be able to see the properties of the column. Then you can make changes if at all required. Common date tables are very important. Assume that you have a sales table with the date columns such as order date, ship date, invoice date, due date, and the like. How easy it will be for you to create reports based on dates. You may have a few more tables with a few more date columns. In such a scenario, it is a good idea to create a common date table which can be used for all date time related calculations. Such a common date table can be built in the following ways. If your source data contains a common date table, better use it. You need not have to create something on your own. Occasionally, source databases and data warehouses already have their own date tables. Or you can build a calendar table using DAX, or you can build a calendar table using M in Power Query. Creating a calendar table using DAX is already explained in detail in part 2 video. So I am not going to repeat those steps in this video. Please refer to part 2 video in the playlist. Build a common date table using M from a blank query using a very simple code. This will be demonstrated in a short while now. Whether you create the date table using DAX or using M, you need to mark it as the official date table. This step is very important. You can then create additional columns such as year, month number, and so on. The mark as date table option is available in the table tools section in the ribbon. Creating and using hierarchies is also an important topic. Please refer to hierarchy creation in the previous module. Parent-child hierarchy is an important hierarchy. As can be seen from this image, multiple employees can have same manager. For example, Guldeep is the manager for a few employees. There is a hierarchy between employees and manager. The manager column is known as parent and the employee name column is known as the child. When you load this data to Power BI, you will not be able to see all levels of this hierarchy. To see more data granularity, you need to flatten this table. The process of viewing multiple child levels based on a top level parent is known as flattening the hierarchy. In this process, you are creating multiple columns in a table to show the hierarchical path of the parent to the child in the same record. You will be using two DAX functions called path and path item to achieve this activity. In a practical scenario, the organizational hierarchies will be used to provide access rights to view your data. You will be able to define row-level security roles using DAX, in which the parent-child hierarchy should be flattened using the path function. We are yet to learn about DAX and about publishing reports. So currently you are provided with just the theoretical information. Demo on these topics will be included in a later video. However, you will be watching a demo on flattening the hierarchy. Role-playing dimensions is yet another concept. A role-playing dimension will have multiple valid relationship with fact tables so that the same dimension can be used to filter multiple columns or tables of data. As a result, you can filter data differently depending on what information you need to retrieve. Assume that you need to compare the profit per order date with that of profit per ship date. You can filter both the order date and ship date using the common date column, which now plays multiple roles. The date dimension table is then set to be a role-playing dimension, and you are requested to please watch the video part 4.2 from 7th minute to 10th minute on this video. The concept of role-playing dimension is clearly explained. Data granularity is another important aspect that you need to know. Have a look at the image on the left side. You have a sales table that stores the records on daily basis, and you have a budget table that provides monthly budget. Data granularity is the level of detail in your tables. In the sales table, the granularity is day. In the budget table, it is per month. These two tables differ in granularity. If you need to show a table in which the total sales per month versus the budget for the month, what should you do? There are a few ways in which this can be done, and I am going to give a demo on one of the methods, which is not the only method, of course. You can watch it while we do the demo. Relationships and cardinality is another topic. One-to-one, one-to-many, or many-to-one, many-to-many are few types of relationships. In the image on the right, the date column from CY table is connected to the date column in the sales table as one-to-many connection. The flow of direction in this sample is from the one side of relation to many side of the relation, which is known as a cross-filter direction. This simply means that the CY table's date column will filter the sales table's date column. In the second image on the bottom, you will be able to see the budget table and the CY table connected through the OEM column. The cross-filter direction is set to bidirection or both, which means both the tables can filter each other. Please be careful. Using a bidirection filter will lower the performance of your model, particularly when you have many-to-many relationship. For one-to-one relationships, the only option that is available is a bidirectional cross-filtering. When you have a population table and a sales table as seen in this image, you can see a common column called state. But the values in the state column are not unique in both the tables. The name of the states appear many times in both the tables. When you connect these two tables through the common column called state, such a connection will be known as a many-to-many relationship. The cross-filter direction in this case can be set in three possible ways, which you will be watching in a demo in a few minutes. You will get a warning on creating a many-to-many relationship as they are little complicated. You need to know about modeling challenges. To effectively visualize the data as per your business needs, your model should be ideal. That can happen only when you establish and maintain proper relationship between tables. Circular relationship will be a common issue everyone will face while creating relationships. You may be creating a calculated column that depends on the values from other columns either in the same table or from a different table. Dependency of column values or measures is another place where you may face problems. A very simple error that can happen while creating a model is the mismatch of data type of columns. As can be seen from this image, the priority ID column in the dimension table is of text type, while it was detected as a numeric type of data in the fact table. Owing to this mismatch, the auto detect feature has failed to create a connection between these two tables. Of course, we can create this relationship in no time, but the point is such minor mistakes may cost us if left unnoticed. These are the points that you are supposed to know in this module. We will be watching a quick demo on this topic now. We are starting the demo part now. We will be doing the first demo for module 3, in which we will identify something about table relationships and cross-filter direction. For this demonstration, I am going to use a sample2 file, that is an Excel file, which contains one fact table called fact transactions and 5-dimension tables such as product, customer, industry, executive, and states. Unfortunately, there are some minor errors in the formation of these tables, owing to which there can be issues in the Power BI model also. And let us examine what the issues are going to be and how we are going to address them. I am ready to load all the 6 tables from the Excel file to Power BI. All the 6 tables are loaded into the model. I'm able to see that they are all connected together. However, this is not a star schema because few of the dimension tables are connected to some other dimension tables, and in turn, only a few dimension tables are connecting to the fact table. I'm also able to see an inactive connection between the product ID columns from the dimension product table and the fact transaction table. Why this connection is marked as inactive? That is because the product ID column from dimension product table is already connected to the product ID column in dimension executive table, and that connection is active. Out of these 2 connections, only one connection can be active. In case if you want this to be inactive and this to be active, you can change that, but I'm not going to do that at this point of time. To give a clue to you on the product table and executive table, I am opening the Excel screen. You can see that there are 5 products available in this imaginary organization, which is being sold by 10 executives. However, please note, not all executives are selling all products. Product ID 10 is being sold by 2 of the executives. Similarly, rest of the products are being handled only by 2 executives. I am now expecting that information to be available in the model. To make things easy, let me dive into a practical scenario of creating a visual, then highlight what exactly is the problem between the product table and the executive table. In the report canvas, I have created 2 slicers to show executives' names and the product's name, and then a card visual to show the total sales value. I want to check what is the sale value achieved by each of these executives. For that purpose, I'm going to choose one executive name from the slicer, then I can see a corresponding value here. Unfortunately, if I'm going to choose a product from the product table, assuming that Aditi Narayan is selling special product also, I'm choosing a special product, then I end up in a blank value. Let me clear both the filters and then now click on the product table and select special product, which is now filtering the executive table to show me only 2 executives, Leela Thomas and Vivek Trivedi, which means that I'll be able to see the special product's sale value is something, out of which the share of this executive, the share of the other executive, I'll be able to see. What is the expectation now? When I click the product table, the executive table is responding to that and clearly showing me only the names of the executives who are selling this product. Similarly, if I'm going to choose an executive name, that should filter the product table so that I can see that this executive is selling this product and that is the value being shown in the sale value card. And that can happen only when the executive table can filter the product table. However, you can now see that the product table is filtering the executive table. The cardinality or the flow of direction is happening from dimension product table to dimension executive table, which means that product table is having an upper hand in filtering the data in the executive table. And the only quick fix, if I want to give an ad hoc solution immediately, is to right click on the connection line, go to properties, and then change the cross filter direction from single to both. This is also known as a bidirectional connection or both. I'm going to click OK to that. Now we can see the change in the icon, clearly informing that these 2 tables can now filter each of them. That is, a cross filter direction is both or bidirection. In effect, if I go to the report view, if I'm going to click on the same executive name called Aditi Narayan, then I'll be able to see that the product table is also filtered. So I don't have any choice to choose any other product, thereby ending with a blank value. If you're asking me a question, Raja, is this a good solution? I will not say that this is a good solution, because having a bidirection filter will slow down your model, and it will also have some other consequences at the time of execution of DAX queries. So the better solution will be to redesign the tables. I'm now going to conclude that we have identified an issue which was solved temporarily by changing the filter direction from single to bidirection. That is the purpose of this particular demo. We will move to the next demo now. The second demonstration is about creating date table from blank query. I would like to click on Get Data Blank Query, which will take me to Power Query Editor. And in the formula bar, I'm going to type the formula, which will give me a list of dates. The formula is trying to start on 1st January 2023, and it will be incremented by every day. The duration is per day, and it will be extended for 10 years. That is the purpose of this formula, and this has in fact created a list for me, and this list should be converted into a table. I'm just going to click OK for that, and then I need to rename this as date, and the data type should also be converted into date. And the final thing, I don't want to keep this as query 1, because date tables are dimension tables. I would like to call them as a dimension calendar. So this is the calendar table that I have created using a M code, which can now be loaded to my model. The dimension calendar table is now getting loaded into my model. I can go to the table. I can see it starts from 1st January 2023, and it will be running for 10 years. The most important thing is I have to click on the column, and then from the table tools, I need to use an option called Mark as Date Table and confirm that this date column is what I'm talking about, and click OK. Now this has been converted into an official calendar table or date table for this particular model. I can create additional columns such as year, month number, quarter, month, and so on using simple formulas like this. And then I'll be able to create a hierarchy called year hierarchy, within which I can include the natural hierarchical items like quarters, months, and even individual dates. So this is how you can create a calendar table or date table from a blank query. Declare that as your official date table. Create additional columns using simple formulas, and then create your own hierarchy. And this hierarchy can be used to construct your report visuals. So that is the end of demo 2. We will be watching demo 3 shortly. The third demo is about flattening a parent-child hierarchy, which involves DAX functions. Since we have not introduced DAX much in this series of videos, I'm just going to give a quick run on this demo. In my Excel file called sample3, I have a simple table called PC table, which contains a parent-child hierarchy. In the Excel sheet, it is not possible for me to see all the levels of hierarchical connections. So necessarily, I need to take this to my Power BI model. And then I'm going to click on Load. And in the table, I'm going to add a new column called path with a DAX function called path. So it is now trying to identify which manager should be mapped for which employee, and I'll be able to quickly create path. This is called flattening the hierarchy. As a next step, I can create the levels by using a DAX function called path item, as you can see in the screen. And this is going to get me the first level of hierarchical elements, which you can see as 1010, because 1010 belongs to Guldeep. He is the topmost hierarchical guy in this imaginary organization. If I'm going to create one more column with the formula as you can see in the screen, this will give me the second level hierarchical elements, and in the same way I can create the third level hierarchical elements also. So this is a very simple technique using two DAX functions called path and path item to flatten an hierarchy, particularly parent-child hierarchy, and that is the end of this particular demo. In the fourth demo, we are going to identify two tables where there is a mismatch of data granularity, namely a sales table in which the records are available for every day and a budget table in which records are available for every month. So the detail or the level of detail in one of the files is a daily record, whereas in the other table it is a monthly record. If I intend to create a report in which I want to see the monthly budget as well as the sales per month, it is going to be a slightly difficult task unless we are able to create some mechanism to match the granularity level. I have opened my calendar template, about which I have explained in the previous parts of the video, and loaded both the sales table and the budget table into that. I am now able to see that the date column from my calendar table can be used to filter the date column in the sales table. I am able to quickly create a connection between them, one-to-many connection. However, there is no common column in the CY table and that of the budget table, and that is what I am going to create now. In the budget table, I have an year column, I have a month column, and the budget value per month. I'm going to create a new column called OEM in which I will combine the data from year column and the month number column, and this will be the result of this column. It will say 2023-01 for January 2023 and so on. In my calendar table also, I'm going to create a similar column in the name called OEM. After creating these two columns additionally in both the tables, I will be able to connect them in the model, and then I need to do a small trick here which is called converting this cross filter direction into both. However, let me not do it at this point of time. I will come back to this and then explain this and then change it maybe in a few more minutes. I will now show you one more information in the Excel file. So the budgets are available for all the 12 months in the given year. That is how normally it happens. Whereas I may not have data for the end of the year. For example, in this particular sample, I have data only till August 2023. You are requested to keep this point in mind. In the Power BI report canvas, I am trying to create a table in which I am getting the month names from my calendar table, sales value from the sales table, and budget values from the budget table. Things are looking to be good, Raja. I am able to see that the sales values are available only till March. You have explained that already. I can see that. The budget values are also captured. Have a look into the Excel sheet. Budget for January is 1368 and so on. Looks like we are doing good. I may need the total for budget also. If that is your question, I have a look at the budget table in which the budget entries are not shown with a sigma symbol or aggregation symbol, which probably means that it is not considered as a numerical value. Maybe I can check that in the table component by going to the budget table, click on the budget values, and then I can see summarization, don't summarize. I can change this to sum, quite possible. Click report view, and then from the table, remove the budget, reintroduce that again. Now you will be able to see the totals are happening, but unfortunately the total for the whole of the year is happening. Okay, so this is where we need to think about how this budget table and the calendar table are speaking among themselves. That is what I was talking about while creating the connection. If I can change this cross filter direction to both the tables can filter each other, and bingo, that is going to give me a solution. But even now, Raja, September, October, November, December, we don't have data for sales. Maybe after the completion of the year, I'll be having data, but I don't want to see the budgets for September, October, November, December in this table at this point of time, for which I can go to my filter span, go to the sales component, and then use a filter called show items when the value is not blank. So that gives me a solution at this point of time. I just want to give you a caution. This is one of the quickest ways in which a result of this kind can be created. However, there are many other ways. Some of them may be even a better way to do this kind of an activity. So the idea is to introduce with you a concept called data granularity, and for that purpose, this demo should be good enough. We will be moving to the last demo shortly. The fifth and the last demo for module 3 is creating many-to-many relationship. for which I have a very simple table setup in sample 5 Excel file, which speaks about a population table and a sales data table. I'm going to take up these two tables into Power BI and then we'll try to create a connection between them. These are the two tables that should be loaded from sample 5 Excel file. Going to load them. The two tables are now loaded into the model. Because this is going to be a many-to-many relationship, auto detect will not create relationship automatically. You need to do it manually, quite possible. So we have a state column here, we have a state column here. The data type is text in both the places. So I think it is going to be easy for me to do that. I'm going to drag one of the state columns and keep it on the other. Then I get the warning message from Power BI saying that this relationship has cardinality many to many. This should only be used if it is expected that neither column contains unique values and that significantly different behavior of many to many relationship is understood. As such, nothing to worry in this case, but many to many relationship is normally a little complicated for the first time user. That's why Microsoft is very keen on providing this kind of a warning message to you. Still we can connect, still we will be able to create some reports out of these two tables. And another important thing about a many-to-many connection is the cross-filter direction can be set according to your business requirement. By default, it will try to open a bi-direction filter, which means cross-filter direction is both, whereas you can populate the filter from either one of the table to the other. For example, here you can say the first one offers sales data filters population or population filters sales data. This is only an introduction part about many-to-many relationship. So we are not going to dive deep into the subject. What you need to know is you will be able to create many-to-many connection, and for that you have three different options for setting up cross-filter direction. We have completed module 3 on this learning path.
Hello viewers. This is a lengthy video, but you are introduced with many important concepts on the topic Model the Data, along with suitable demonstrations. Please provide your comments that can help us improve our videos. Please like the video if the contents are good, and share this with your contacts who may be interested in learning Power BI. Thank you for watching. See you in our next video.